77 Tech.
I'll be talking about functional programming in Python. Okay, so let me get into Python shell. Okay. So functional programming typically means that you will be treating functions as objects. Okay, yeah, you got it right. You will be treating functions as objects. Okay, the idea of functional programming, and it's very popular these days with technologies like Spark and all this coming into picture, where you want execution responsibility of a function to be moved down to the driver code rather than application code. Okay, what it means is the way to suppose you have a multi-threaded multi-core platform. Your application program should not be the one who should be taking responsibility of deciding which code to use, how many threads to use, and blah blah and all that. It should be the responsibility of your executing like platform. Okay, let me show a bit about it, then I think you'll get more hang of it. Okay, so in Python, first thing, how you achieve this is using lambda. What is lambda? Lambda is anonymous function. Okay, how do you define a lambda? Suppose this is what you're trying to do. Okay, x star 2. So what this line means is, this is in the right hand side of the equal to, what you're trying to do, you are trying to define a function which takes one argument, that you see one argument, and returns twice of that. Okay, so this is, you're assigning this function to the value f. Okay, to the value, yeah, to the value f. So if you want to print the type of f, you see a function type. Okay, so f is an object now. Okay, and which is holding this function. So if you want to execute f, do this. Okay, so it is like this. So similarly, you can have a function which can take two arguments, lambda x comma y, x plus y. Okay, g5,6. Okay, so you just defined an anonymous function which takes two arguments and returns sum of them. Okay, so let me use it, and suppose you have there's an inbuilt function in Python that is sorted. Okay, so what you can do is, using this you can actually sort any type of thing, any format of data. So let's see, suppose you have a L like this, 1,2. So this is a list of tuples, 1,2, rather zebra. Okay, so it's a tuple of number and string, 4, cat. G, lion. Okay, and 88, that. Okay, and then 7. Okay, so we have a list of tuples here. Okay, we want to sort it based on the alphabetic based on the words here. Okay, so for that you can use the sorted utility, and the best way to learn Python is from help manual. So do this, sorted. So you'll see the way by which you can call it. The first is iterable. Okay, so you do this, sorted L. Okay, then you give one of these. So I want to give this key function. Okay, so you can key a function actually takes an argument that will be a tuple every time, and it returns any one of them. Okay, So now it will be sorting the entire content based on the first argument. If you want to make sure, if you want to have it based on numbers, you do this, right? So what you're doing here, you're passing the function here itself. So who is you're passing the function here. Who is executing the function? The function is being executed by your platform. Okay, so if it wants to use platforms multi-threaded infrastructure to do this, it will be available to it. Let me show one more thing. Okay, the other thing is map. Okay, suppose you have a list like this. Okay, let me make it a easier one so that we can understand it well. Suppose you have a list of numbers. Okay, and you have map means it will convert for each element. Okay, it will be executing the function that we mentioned here. Okay, again, always before doing this, help map. Okay, you'll see the function name and the sequence. Okay, so how you write it? Map function name. Okay, lambda x. This will be the function which will be taking one argument here, and x is equal to 2. Okay, and the m, right? Yeah, it will return a list where this function lambda x, it's not that that you cannot write a normal function over here. Of course you can. Okay, and lambda is typically to write smaller functions. Smaller functions where you don't have a lot of logic and all that. So in this case we use lambda because we are providing the function to map here. So map internally takes the function, executes this function with each element, so it can do it in parallel threads. Okay, that will very much optimize the function. Okay, so this is what it means. So having said that, you can actually define a function like this which takes one argument. Okay, return x into 3. Okay, and you can pass here f. Okay, so this was about map. Similar to this, we have filter. Okay, so what you do with filter is, filter will actually from your data structure, right? Not necessarily lambda x dot starts with among, suppose you are passing a list here, it will return you all the words which is starting with A, say ABC, D, F, E, Z, X. Okay, you can see here, this is this lambda function. So what happens here is, this function, whatever you see here, executes on each element, and it will return true for whichever this condition is true, and whichever the condition is true, it will return you a list containing those elements. Okay, this is how the filter works. Okay, similarly we can have the third thing here, filter, map, and reduce. Suppose reduce means you can do some operations here. Okay, so for example, I'm using the same content here, m. Okay, reduce same content. Now whatever I write here, okay, lambda x comma y. Okay, here you're doing x plus y. Okay, that means what will happen, first two element is taken, the result is obtained x plus y. The resultant is used with third element. Okay, the result is obtained, that is used with fourth element. That is how it works. So if I do this, it will give me sum of all the elements in the list. Is it clear? So we have a small bit of functional programming here. Then you have a lot of other inbuilt things like iter tools. Okay, to help it. Sorry, import iter tools first. Yeah, so this is iter tools library, very useful stuff. Okay, then you have things like yield generators. Okay, that will be all from Python. Okay, I'll be talking a bit about, let me talk about Hadoop, maybe introduction. Okay, what Hadoop is, a brief, some brief of it, then I'll go to the architecture side of it. Okay, so what I'll talk about is, yeah, we understand big data. Okay, but what is about? So big data consists of data. The data falls into big data category if it matches with four V's. One is volume, one is velocity, uh, one is volume, velocity, veracity, and okay. And what do we let's talk about volume of data that is happening these days. Okay, so uh, the volume of data that is generated by, I mean, I'll show some staggering numbers here. Second, stuck. Yeah. See, with the volume of data that is generated these days is like, yeah. Uh, See, this is the volume that is generated. So, there is this very important aspect, your website journey. Okay, companies store that as well. Website journey means when a visitor visits a website, how is he, traveling through your website. This is huge amount of data. This is stored. You and doing the analysis of that gives the insight to the companies, how is user interacting with the website and how can they make it better. Okay, so that users spend lesser time and get buy more product. Okay, so there are a lot of such things. Okay, so similarly, there is a very interesting story of this guy, beer and diaper. Okay, very interesting. I mean, this is known as beer diaper syndrome. Folks are not aware of this. Okay, what happens in beer diaper syndrome is typically there was a research that happened on I think happened in Walmart US 90s. Okay, so what was the research? They wanted to find out which are the two products which they should keep closer. Among various other results, this was one, which actually became a case study for management. So what they found out is, among many other things, beer and diaper, people have a tendency to buy them together. Yes, you heard me right, beer and diaper. So there was, of course, I mean, analysis was not that difficult since in US, married people tend to stay at home. Okay, and I mean, they don't have to go and drink outside generally, and since they're married, heavy chances of getting a kid, and since the mother was recently pregnant, uh, carrying all this stuff would be typically men's job. That's the reason why, beer and diaper makes good combo, and sometimes they want to de-stress themselves from these early kid activities and pick up bottled beer as well. Okay, so that was the analysis. So similarly, when you see the retail market, this is the way things are kept and all that. It's not really at all. There is a lot of research going on beyond that. So when you have this analysis to make, life comfortable of people, right? I mean, the very important aspect where big data is picking in, because you can personalize a product for them. Okay, so personalization, data analysis, prediction, all these areas are the part of, or your big data ecosystem. And it is somehow, the entire story was started by Google in 2004, but it has been some time now. Okay, storage is cheap. One more reason for companies can make money out of it, and it's cheap. Why they don't do that? Okay, so when you have huge amount of data, there are two inherent challenges that you face. Okay, one is your storage, because in one storage system you cannot store more than 1 TB of data, 16 TB of data. That is the maximum tech that you see by 2015-16 time frame. You cannot store more than 16 TB. So anyway, you have to store petabytes of data that get generated every day. Okay, so how you do that? You actually break down the data into pieces and store in different machines. Okay, so that is known as distributed storage. Okay, you actually don't have to do that. Hadoop will take care of breaking down the data and storing in different machines. Okay, this is known as distributed storage. Second part of it is, okay, since you have already stored the data in different machines, okay, actually, and the other interesting part of Hadoop is it can use this commodity hardware, that means cheap hardware. Okay, and when you're using cheap hardware, chances of failing is not really that low, it's high. Okay, so Hadoop takes care of that fact of making sure it maintains the backup, it takes up care of redundancy, high availability. Hadoop takes care of everything. As well as what it makes sure is when this data is available in different systems, okay, it can do parallel computation. Okay, so that it can harness the power of different machine simultaneously together. And if you want to increase the power of this cluster is such collection of system which will be providing your Hadoop functionality. Okay, so if in a cluster, okay, if you want to increase the computation power of it, you just have to add one more machine to that. So scaling is really easy with Hadoop. Okay, so we are into Hadoop 2.0. These guys, I mean, the guys who actually did everything in the beginning were from Google, Manoj Shekhawat and Jeffrey Bean. They were the pioneers into Hadoop. Then Apache implemented it, and 2014 Hadoop 2.0 is, I mean, since 2014 we're using that. It consists of three major parts. These are the uh, big, I mean, Google's servers that looks like paddy fields of Antico. This isn't it. This is how it looks from inside. Okay, so coming back to so coming back to your Hadoop. Okay, it consists of three major parts. One is HDFS, Yarn, and MapReduce. HDFS is typically responsible for storing the data. It's a file system. Like we have NTFS, FAT. These are file systems. So we have HDFS. HDFS is Hadoop distributed file system. It's a file system which runs on top of your native file system. Okay, it is this file system which actually takes care of the responsibility of breaking down the data, storing in different nodes. Okay, that is HDFS. Then you have Yarn. Okay, Yarn is more like a scheduler in OS. So again, Hadoop you can imagine it is a distributed OS. So what is HDFS? HDFS is mostly consists of two parts: name node, data node. Okay, I'll come to name node, data node, but name node you can imagine as something like which store metadata of the files. Like you have huge amount of files scattered across different systems. How do you know where is what? Okay, you store this information in HDFS. Yarn takes responsibility of executing some task, scheduling resources. So the full form of Yarn is of course yet another resource negotiator. It schedules the system, schedules the memory, schedules the process, see what has to be executed here. We'll talk deep about it. And MapReduce is typically a functionality defining framework. What you do over here is you define the mapper, you define the reducer. Okay, mapper is that piece of code which gets executed on each node. Okay, reducer is that piece of code which actually executes the results that it obtained from the mapper. Fine. Okay, so that is your MapReduce framework. Okay, so in this course, what we learn more about is what internal is, how is HA achieved in high availability achieved in Hadoop, how internal things gets done. Then we will use things like Pig, Hive, Woozy, Flame, Flume, and all this to do some operations and get some hang of it. Then we'll do some real world projects to get a deep understanding into various aspects. Okay, so yeah, I'll put an end to the demo session today. Okay, Suraj, you're around?